12 advance, end of term 1 revision. 2.2. The figure below shows the magnetic field around a bar. What are the north and south pole? I can see that the magnetic field lines are going out of 2, so 2 is the north, and going into 4, so 4 is the south. As the magnet below in the figure moves toward the suspended magnet, what will the magnet suspended by the string do? So I can see that this one is fixed, and this one is suspended. Same pole, north with north, they repel. So basically, this one will move to the left. So what will the magnet suspended by the string do? It will be repelled to the left. So 2.2.2, describing the field lines. Which of the following are true regarding the magnetic field lines? Eventually, the magnetic field is, yes, a vector quantity. It has magnitude and direction. And field lines are drawn from the north seeking pole to the south seeking pole. That's all correct. The field lines drawn closer together imply not a weaker field, a stronger field. And the field lines, they never cross each other. So when it comes to sketch and interpret the magnetic field pattern, question number 5, the current in a wire is coming straight out. So when I apply my right hand rule, the first right hand rule, the fingers will curl anti-clockwise. Question number 4, also I have my current upward, and my fingers, I will apply the right hand rule 1, placing the current on the thumb and the magnetic field on the other fingers. So the direction of the magnetic field will be anti-clockwise, and it is inside the frame, inside the card. So the answer is A. In an experiment, a student has a wire carrying a current out of the page. So dot means out. Question part A, on the figure, draw the magnetic field pattern due to the current, clearly marking the direction field. So inside the magnetic field, they are close to each other, and out a little bit further, I will draw a field line that is quite further than the first two, meaning that there is a weaker magnetic field, and by curling my fingers, the magnetic field will rotate anti-clockwise. What happens to the magnetic field is, if the magnitude of the current in the wire increases, so we have a relationship that says I is directly proportional to the magnetic field strength. So as I increases, the magnetic field also increases. The second question, what happens to the magnetic field if the direction of the current is reversed? Also B will also be reversed. Okay. Question here, 2.2.5, determine the strength. I will apply this equation. I can see that the how is the strength of the field at distance r from the wire center related? I can see that there is a direct relationship, inverse relationship between B and R. So it is inversely proportional to R. Question 7, you have a 10-meter long, this is the length, wire, I equals to 4. What's the magnitude of the magnetic field at a distance r 0.05? By applying the equation mu 0 over 2 pi r. So here the length has nothing to do with me. So again, mu 0 is 4 pi times 10 to the power of negative 7. That's a given. I is 4 over 2 pi. The distance is 0.05, not squared. And the answer is B. The unit in Tesla. Now, question number 8 and 9 are related. A long straight wire carries 2.10 amps at a distance r equals to 3.5. Not to forget that I need to convert this. So basically, finding the magnitude of the magnetic field, it is mu 0 I divided by 2 pi r, 4 pi 10 to the power of negative 7. I is 2.1 divided by 2 pi. Not to forget that it is a 3.5 centimeters, 10 to the power of negative 2. The answer is also B. The unit is in Tesla. And when it comes to curling the fingers, I will point my thumb in this direction and my other fingers will be curling like this, and they will be going here outside of the page. So, and P is above it, above the current, so it is out of the page. Question 5, very similarly to the previous question. What's the magnitude of the magnetic field at point P, given the current, given the distance? Not to forget that here also the centimeter to be converted. So B equals to mu 0 I over 2 pi r d anything. So it is 4 pi 10 to the power of negative 7 by 3.4 divided by 2 pi multiplied by 6.5 10 to the power of negative 2. The answer is 1.05 10 to the power of negative 5. The unit of the magnetic field is Tesla. And when it comes to the direction of the magnetic field, I will put my thumb up, and next to it on the right it is inward, and here it is outward. And P is in the region that is inward, so it is into the page. You can write into the page, you can put a cross, anything that tells me that it is in the page, into the page, or cross. And that's it.